So I was driving to this conference 2 days ago, so everything was fine, and then suddenly, bam, I had a flat tire, and then I had to deal with it like on the go. So among all of you, who has been there in that situation where you had to deal with something you didn't expect? Would you mind sharing hands? Okay, almost everybody. I got your attention. Hopefully it does help getting that adrenaline kick after the heavy lunch. So now imagine something with wider impact. So a few months ago, maybe some of you could recall, there was a single change that impacted Windows systems globally. There was a single change that produced like a massive impact, a global impact. Do you guys remember that? Yes. So a few things that we can learn here is that failure happens, it's part of life. So the key is for us to be able to be ready as when it happens. The question is when and not if. It will happen. So how do we design for it? How do we embrace failure as part of day-to-day, and how do we design for that? And that's where high availability comes in. So to keep things running, we want to make sure that we keep a couple of key principles in mind when designing systems. So number one is fault tolerance. When failure occurs, we want to make sure that our systems keep running. And then number two is isolation. So when something fails, we want to make sure that it does not bring down the whole ecosystem with that failure. And number three would be redundancy. Redundancy means you have a backup, something to fall back to in case something fails, especially the application state that is very critical to the way that things operate. So focusing on these principles, we can keep our systems running even though the unexpected happens. So just a little bit about myself. My name is Samuel Cosilo. I'm the head of event streaming, as introduced earlier. And I am, just a little bit about Charles Schwab. We are the nation's largest publicly traded investment firm, managing more than $9 trillion of assets of our clients for about more than 35 million clients. So it's a big deal for us to make sure that our systems are highly available, and we empower our clients to take control of their financial futures through investment products, services, banking, trading platforms, and many more. And I'm very, very fortunate today to be working alongside some of the brightest individuals that I've known in my career to be able, and these individuals are actually here in this room, so in case any questions come after the sessions, I can have them help answer some of those questions. So we support thousands of apps interact, as you can see some of the numbers here, and interchange data in a secure and reliable fashion across thousands of data products, processing more than 1 billion events per day. So we process these critical workflows under 1 millisecond latency, and during high bursts, as we are talking right now, there is a federal rate announcement being made. They cut the rates by 0.5. So during these times, we are able to process more than 2 million events per second, essentially. So today I'm excited to share how we leverage some of these principles in our business. So now let's rationalize quickly about how we can approach the availability problem. So the key topic today is availability and how we strive for that high availability. So first of all, not all applications and business requirements are the same. So understanding your business needs is going to be key to define the right and effective strategy for your business. So to simplify our discussion today, I categorize that into 4 different buckets based on their availability guarantees. The 2 nines, 3 nines, and 4 nines, and beyond 4 nines, essentially. So the first one, 2 nines, these are only suitable for less critical applications. So in general, unavailability here is basically an inconvenience. So this is not a category of apps generally that we would use for our clients. So the second one, we are looking at 3 nines, which is for apps that require a little bit of higher availability. It permits around 8.5 hours of allowed downtime per year. However, per Gartner research, they reported around average cost of downtime of about $5,600 per minute, which could translate, if you actually do the math on that 43 minutes allowed downtime per month, we are looking at around a risk of $240,000 a month, which is quite substantial. So the third one is probably the sweet spot for a lot of businesses. e-commerce sites, for example. So it allows about 50 minutes of downtime per year, as you can see here on the chart. And then this is something that is not a lot, but potentially can be managed. And then beyond 4 nines, which is the category at the bottom there, it aims essentially for virtually no downtime. And this is for ultra-critical systems that must remain operational at all times. And then following here is the summary of the quote-unquote Kafka architectures. We did the best we can to ensure that this slide can be easily interpreted and can be easily followed. So at the top there, we have single zone. Essentially, you have a single zone, availability zone for your cluster. And then the second one is multiple zones, multiple regions, and multiple clusters. Essentially, that's how it's broken down based on the availability guarantee. So now let's look at the details. And for the sake of time, I'm going to jump straight to the second one and skip the first one. So for 3 nines, as we discussed earlier, we implement multiple availability zones, obviously to mitigate against zonal failure. So in here, we depicted and set up 3 different availability zones. For each zone, generally, if we talk about Kafka language, you would have each zone comprises of 2 brokers at a minimum, 2 zookeepers at a minimum, and if you don't have zookeepers, then that's great. And then 1 schema registry, and then a replica, a minimum replica of 3, so that you can have a replica in each of the availability zone, and the minimizer of 2, which allows active-active, essentially at a minimum of 2 zones. So this provides you isolation at the zonal level, as well as provides ability to perform active-active, state active-active for your applications. So expanding from your previous approach, we are looking at 4 nines here, where we add additional regional resilience, essentially. So in the case of a winter storm, where it took down the whole region, you would have the ability to fall back, essentially, to a DR cluster, in this case, in another region. And the next one from here, as our business and systems continue to grow, there will come a time where a single cluster is no longer enough, essentially. And then beyond number 1, we want to make sure we have scale, right? And then the second one is we want to be able to minimize impact, because we don't want to be in a situation where we can't recover, and we want to make sure that we can cover the blast radius of the change that we discussed earlier in the earlier part of the talk, of any single change or failure even at the cluster level, right? So if you're doing a major upgrade, if you're using Confluent platform, you want to make sure you are mitigating against that, or any authentication failures. If you have any dependencies, any authentication engine, you want to make sure it does not impact and bring down whole clusters, right? And the third one, obviously, as we grow in our business, we want to make sure there is a mitigation and isolation against noisy neighbor. So hence, we introduce the multiple clusters, basically. Similar principles, redundancy and isolation, we introduce multiple clusters. So there's a couple of key concepts here that have changed between this one and the previous one. So first is about the active-active capabilities across clusters. As you can see here, previously is 1 primary and DR. Now we are looking at active-active. So this means that you can have to shard, and there's a couple of different ways to shard the application state. There are a couple of other talks that cover that, so I will not go into the details on this talk. So secondly, to keep things operationally simple, we are Confluent, we partner with Confluent, and we actually leverage their multi-region cluster to make sure that we have operations that are simpler to manage and allows us to cut down the number of clusters we have to deal with. So that multi-region clusters architecture allow us to set up observers in another region, and thus allow us to cut down the number of clusters. So one crucial thing to keep in mind here is that wherever possible, we want to make sure that these 2 clusters are isolated. If you have any dependencies, any resources, any network resources, certificates, if you use Active Directory service accounts, maybe open OAuth APIs, you want to make sure that they are all isolated so that when one is impacted, the other one is still available. So through these multiple clusters, we can now better segment, isolate, and optimize our workload. I think I ran out of time. So I will go ahead and jump to the last slide. I will close the talk with 3 questions for you. So number 1, do you have different SLAs across boundaries? Some of them hard SLAs that you have to manage. So number 2, how varied are your requirements, specifically around regulatory and compliance in your environment? And number 3, do you need to fine-tune and optimize for your workloads? And then are they highly different that warrants a different or a separate cluster? And thank you for your time.